Good morning, guys. This is Wednesday, February 2nd for KAP. We're starting with this warm-up activity, and I'm going to give you all a few minutes just to talk about the difference between, and I didn't say this, KAP stands for constant of proportionality, and CROC is our constant rate of change. Take a few minutes, pause, and reflect. What are differences between the two, and then what are some similarities? After you've gotten a few things, as much as you can remember, we'll go over it as a class. Pause and play when you're ready. All right, so we started, someone said that they both have to be linear. That is correct. Pause, I'm going to recalibrate the board. Here we go. So they both have to be linear. What's something else? Heyman. They both are constant. They both have the word constant. Great.
They both need an X and a Y.
They both need an X and a Y. Yep.
I have one
For
constant of proportionality.
Yeah.
Is measured the ratio of the change in Y in only multiplicative relationships.
Okay, so that was a lot of information. She used lots of spicy words. She was talking about ratio. She said it was the ratio of. That is for the CROC.
Changing Y to changing X and only multiplicative.
So when we're saying the change in Y over the change in X, that's going to be with the constant rate of change, because the word change, constant rate of change, is the change in Y over the change in X. What the COP is, it's the ratio of just Y to X. Y to X. There is a difference, because in this one, you're finding how much is changing in between each point. This one, you're just finding a point, putting it one over the other. She also said that just for COP, it has to be a class, what kind of relationship? Multiplicative. And honestly, I would say that multiplicative is a common thing for them. Multiplicative. But rate of change can also be what else? What's unique to rate of change? No. Boys, let's focus. If this is just multiplicative, I don't want to just follow her. It has to be additive. There's another type. If it's not additive and multiplicative, there's also the two-step. Y'all agree with that? Like when it's multiplying and adding, or multiplying and subtracting. Okay? A rate of change can be had in those kinds. What else? It can be any linear relationship, so we already have that. Very good. Let's talk about the equations for each. Like remember that parent equation, that template that we can put them into? What are those templates?
The template for CROC would be Y equals MX.
Y equals MX. Very good. Y equals MX plus B versus COP would just be, very good, Y equals KX. We use K for the constant of proportionality, and we use M for the rate of change. Okay? You could honestly put this is equal to K and this is equal to K if you want like definitions. Okay? What are some other words for the rate of change? Slope, very good. In both cases, we sort of call them the multiplier. Okay, that's where it's confusing, because at times the constant of proportionality can be the rate of change, but only when it's a multiplicative relationship. Michael? Yeah? No?
No,
Okay. Okay, so if we think of stuff throughout the class, we can always come back to it, but we really just need to be able to tell when they're the same, when they're the different, how to find each one. So what we're going to practice today before our ticket at the end of class is just what's going on. So on the inside of your packet today, you have an assortment of columns. You have tables, you have graphs, you have equations. You're going to go through and you're going to determine, does it have a CROC? Does it have a COP? Does it have both? Does it have neither? Okay? So maybe I'll do one or two with you, and then you can see and get the flow of it and just be able to tell. So we're going to work through each of the situations to find if it's one, the other, or both. If it does have it, it does have a constant of proportionality, find it. If it does have a rate of change, find it. okay, and you'll write it down. So let's just do one together, just so you have an idea, get the flow of things. Okay, so on this number one, I have a table. So let's start with the concept of proportionality. To find k is equal to what over what? Y over x. So you just pick some points. Okay, so I have a table full of points. 5 over 1 simplifies down to 5. Okay, do the next point. 6 over 2 simplifies down to 3. Does this problem have a concept of proportionality? No. Okay, so I'm going to cross that out. Okay, the next one, CROC. How do I find the rate of change? M is equal to, very good, let me do the color, change in Y over the change in X. So let's find that. Again, this is where I'm going side to side. What is my change in Y each time?
1.
Plus 1. Do y'all agree? What's my change in X? Plus 1. Okay, if I put that change in Y over that change in X, simplifies down to, does it simplify to 1 for every single one? 1 over 1?
Oh, yeah.
It does, okay? So does this problem have a constant rate of change? Yes, it does, okay? But it doesn't have both. It has a constant rate of change, and that rate of change is 1. Y'all, are y'all good with that? Okay, are y'all sort of seeing the differences? Yeah.
Wouldn't there be like a white?
There would be a y-intercept. We're not really focusing on that today, but there would be. Because this one, what kind of relationship is this table? To go from 1 to 5, 2 to 6, what's happening each time? It's additive. It's plus 4, so that y-intercept would be 4. Okay? But we're just looking for the rate of change or the constant proportionality. Okay? Do I need to do another example, or are y'all good? Are you sure? Yes.
Just want to ask one question.
Yeah. Yes.
So it's not multiple origin.
Yep.
It's not multiple. Both of them have to be multiple.
No. So let's just do one. She already said what makes this not constant. Someone else say it. What did she say? This is not constant because, Devani? Very good. Like, I wouldn't even bother doing the points. I would say not through origin. Not through origin, so it does not have a constant of proportionality. But for the constant rate of change, again, the only qualification really of a constant rate of change is it's linear. Is this problem linear? Yes. Okay. To find that rate of change, we need at least 2 points. Okay, so let's get 2 points. Here's 1 point. I can't see, so I'm going to do this point because I see it crosses nicely. So the first ordered pair would be 0, 10, and my other point, this is 4, 20. Okay, so my rate of change, I might make a little mini table x, y, 0, 10, 4, and 20. Find that rate of change. Change in y is plus 10. My change in x plus 4. I put what over what? Change in y over change in x, 10 over 4. You can do that math, simplify it down. That is your constant rate of change. Okay? So, again, we need to iron out and figure out, okay, this is what it looks like, this is what it doesn't look like. And go through that and practice that. So, you have plenty of problems. Pause and, like, literally work through both of those pages. And I'll give y'all some time. Once y'all do that, we'll go over it, and then we'll take our ticket. We'll have to amount of time. And we'll have time to ask questions. Please take this time to ask each other questions, ask me questions, get out your notes. Those notes, as soon as y'all see it, you'll be like, oh yeah. Okay, y'all got this. Okay, so pause. Honestly, if you're at home, give this like 15 or so minutes to finish all these problems and we'll go over it. Okay? All right, we're taking a pause. We're before I show the answers, we're talking about 7 with my class because it's like literally their favorite problem.
No.
I keep asking you about it. Okay, pause. Okay, let's just go back to the definitions. How do I find k, the constant of proportionality? I put y over x. Y over x. So put y over x, 7 over 2 simplifies down to 3.5, 3.5, 3.5, same thing. Okay, do it for another one because I need to see that it's constantly that same proportion. So if I put 10.5 over 3, if you actually work that out, 10.5 divided by 3, it goes in 3 times yellow green, 9, I get left 1, bring down the 5, bring up that decimal so we don't forget. 3 goes into 15. Is that the same number? Is it constantly saying the same thing? If I do 28, I did it with Parker. If I did 28 divided by 8, Parker, what did you get? 3.5. So if it's saying the same the whole time, isn't that a constant of proportionality? Yeah. So I'm just going to put a little check mark saying, yeah. Let's look at the constant rate of change, because this is the thing that I think is throwing out a lot. So if I go from this one to this one, what is that?
Plus 3.5.
3.5, and this is plus 1, okay? If I go from this to this, it was plus 7, and y'all are like, oh, no. But did this one change as well?
Yes, plus 2.
Plus 2, okay? But remember, sometimes we just take out points and we don't put them on there just to make you question it. But you have that definition. To find the constant rate of change, we put the change in y over the change in x. Y'all agree with that statement? Okay? For the first set, 3.5 and 1, that simplifies to 3.5. Do we agree with that statement? Yes. If I put 7 over 2, what does that simplify down to? 3.5. Is that the same number? Yes. Just because it doesn't have all of the points doesn't mean it's not a constant line. Okay? This Lidl is making you question yourself.
Why?
Because I like
That's mean.
I know. Okay? So this has both. Okay? Those decimals and fractions, y'all are solid with whole numbers. But as CAP students, you also got to do the nitty-gritty rational numbers. All right, keep working. A few more minutes and we'll go over it. All right, looking at these answers, number 1 we did together. Number 2 only has a constant rate of change. 3, because it's additive, it only has a rate of change. For both 5, here we go. Scrolling, 5 only has a rate of change. 6 has both, it's multiplicative, yes.
Here's X on 3, 11.
On 3, it is equal to 1.
Okay.
1, I don't know what happens in that, but it's 1.
Can you explain
Number
number 2?
2, over there, with part.
So I got 2 and 2.
I used the point 420 and 830 to change the rise. They did rise over run, so up 4 over 10 simplified to 2/5.
But wouldn't it be 10 over 4? Because wait, I don't do the whole.
The change, the rise over the run. The change in y is 4, the change in x. Are you good with that? Okay, Hannah.
So I got 2.5.
Repeat that.
2.5.
It's 2/5, which is 0.4. You did 10 over 4. You did the same thing. You did y. You did x over y. Oh, okay. Sorry. Sorry, I didn't understand what y'all were saying. That should be a rise of 10, and then it went over by how much?
4.
You'll do great. Always point out the mistakes. All right. So it'd be, yes, it would still have a crop, but it would be 2.5, not 0.4. Sorry. Y'all are good. Y'all are better than me. Okay, back page. 7 is both. 8, just the rate of change. 9, rate of change. I'm sorry? Okay, please only talk if you have a question. 10 is both. 8, it does not go through the origin. Number 8, I just looked at it. The graph is a little, so don't worry about it. Okay, you would do the normal stuff, but the graph is very unclear, so we're going to take that for next year. Okay? All right, once you're done, please put everything away, grab offices. For those of y'all at home, we're taking a ticket. Please rearrange with your teacher. Take that.